Hello everyone, welcome to Math Help Sessions. My name is Sathana, and in today's video we're going to be looking at what the Pythagorean Theorem is and how we can use it to help us solve different questions. So let's get started by looking at the basic structure. The Pythagorean theorem is a theorem that we can use to relate the three side lengths of a right triangle. A right triangle can be identified as a triangle which has one angle is exactly 90 degrees. And in a regular triangle, this can be identified using a little square. And this means that the other two angles of the triangle are automatically less than 90 degrees or acute angles. The two side lengths which are connected to the right angle are called the legs of the triangle. And the third side the diagonal of the triangle is also called the hypotenuse. Now, if we wanted to label this triangle in accordance with the Pythagorean theorem, we can label the two legs as side lengths A and B interchangeably, meaning it doesn't matter which one you call A and which one you call B, but the hypotenuse will always be called C. And the reason for this is because when we're using the Pythagorean theorem, this is where the three variables are which will help us to solve the Pythagorean theorem. So what is the Pythagorean theorem? The Pythagorean theorem states that a squared plus b squared equals c squared. What this means is that if you take the square of this side length and you add it to the square of this side length, it's going to give you the square of this side length. And with the Pythagorean theorem, what you can do is, if you have only two side lengths of the triangle, you can always solve and find the third side length of a triangle. And this works for any right triangle, and because it's a theorem, it applies with any of the three side lengths, meaning you can solve for any of the three side lengths if you have the other two side lengths. So let's go ahead and look at some examples. So example number 1 states that the two legs of a right triangle have side lengths 8 centimeters and 15 centimeters. What is the length of the hypotenuse? So whenever I like to solve a question, I start by stating what is given to me and what is unknown, so I can clearly know what I want to solve for in case it wasn't clear from the question. So here it says that the two legs of a right triangle. So this side length and this side length have to be the legs of the triangle. And it says that they're called the side lengths are 8 centimeters and 15 centimeters. Now, because based on inspection, they look, very similar in size, I'm just going to call side length A here 8 centimeters and side length B 15 centimeters. And because it's asking us what the length of the hypotenuse is, it means that we're solving for this side length here because it's not given to us. So let's go ahead and write that down. We know that side length A is 8 centimeters, side length B is 15 centimeters, and we're solving for side length C. So in order to solve this, let's bring in the Pythagorean theorem. And it states that a squared plus b squared is equal to c squared. Now, because we're solving for side length C, let's go ahead and isolate by bringing side length C to the left side of the equation. So we can rewrite it that c squared is equal to a squared plus b squared. And now, in order to isolate for side length C, and we need to square root both sides. Now, when we're square rooting both sides, it's important to remember that whenever we square root something, our values will always be as a positive number and a negative number because squaring both of them will get you back to the same square. So what we do is that we think about it from a logical perspective. So if we're trying to solve for the side length of a triangle, we know that it cannot be negative. And because we know it can't be negative, whenever we're using the Pythagorean theorem, we can always assume that we're always going to be taking the positive side length that comes from square rooting from the Pythagorean theorem. So let's go ahead and square root it. Now, because we've isolated for C all by itself, we can substitute the values that were given to us in order to solve for C. So let's go ahead and substitute A and B in. And it states that the square root of 8 squared plus 15 squared. And if we evaluate this, we get 64 plus 225. And if we add them together, we get 289. And if we square root 289, it's going to give us 17 centimeters. And it's always important to use units, especially if it's given to you. So what we know now is that the two legs which were given to us, side lengths A and B, were 8 centimeters and 15 centimeters. And what we were able to solve using the Pythagorean theorem was side length C, also known as the hypotenuse, which was 17 centimeters. And that's it for example number 1. Let's move on to example number 2. This states that a right triangle has a hypotenuse of 13 centimeters and its shorter leg is 4 centimeters. What is the length of the longer leg? Round your answer to the nearest tenth. So Let's go ahead and again start with the basics, labeling what we know and what we don't know. So it says here that the hypotenuse is 13 centimeters. Okay, so we know that this side has to be the side has to be the hypotenuse because it's labeled side length C, and it's the diagonal looking side length. So we know that C is equal to 13 centimeters, and it says that the shorter leg is 4 centimeters. Well, based on inspection, we can see that the side length A is slightly shorter than side length B. And so because of that, we can just say that let A be equal to the shorter leg, and therefore A is equal to 4 centimeters. And what this means is that we're solving for the longer leg, and that means we're solving for side length B. So let's go ahead and write that down. So now let's bring in the Pythagorean theorem to help us solve this. Again, A squared plus B squared is equal to C squared. Now, because we don't know what B is, we want to isolate for variable B. So let's go ahead and do that. So B squared is equal to C squared minus A squared. And we did that by subtracting A squared from both sides. Now, again, because we want to isolate for just B, let's take the square root of both sides. And because it's a side length, we're always looking for the positive answer. So B is equal to positive square root of C squared minus A squared. Now, because we've isolated for B, let's go ahead and substitute the two values which are given to us. So B squared is equal to the square root B is equal to the square root of 13 squared minus 4 squared, which is 169 minus 16, which is the square root of 153. And it says to round your answer to the nearest tenth. Now, because 153 is not a perfect square, when we square root this, it will not give us a whole number as its square root. And because of that, and it's asking us to give it to us in a decimal answer, we can square root it and get rounded to the nearest tenth. So when we do that, B is equal to 12.4 centimeters. Now, again, to recap, we were able to get side length A and side length C from the question, and we were able to solve for side length B, which was 12.4 centimeters. And this triangle is complete, and because we know all three side lengths, we know we're done with the question. Let's move on to example number 3. Example number 3. So this is a word problem. So let's read it very, very carefully to make sure that we understand exactly what we're looking for. Against a house, a ladder is leaning diagonally from the top of a ladder touching the house and the bottom of the ladder touching the ground away from the house. If the ladder is 1 meter long and the base is 0.7 meters away from the house, how far up the house does the top of the ladder rest? Leave your answer in exact values. So, because it's a word problem and no visual is given, it's very important for us to first visualize what this question is giving us. So let's go ahead and build a visual for this. So we have a house and we have a ladder leaning diagonally with the top of the ladder touching the house and the bottom of the ladder touching the ground away from the house. So here, the key to solving any word problem which involves the Pythagorean theorem is being able to identify where that triangle is, which of the three angles is the 90 degree or the right angle, and which of the three side lengths is the hypotenuse, because identifying those two key points will give us the reference point for the rest of the triangle. So we can see here that this sort of looks like a triangle here, and it's asking us for how far up the house does the top of the ladder rest. So because we know that this is our triangle, let's go ahead and simplify this into a triangle format. So we can take this triangle and just redraw it as a simple triangle here, where we know that this length would be the house, this length is the length of the ground, and then this is the length of the ladder. And we see here that this has to be the right angle, so we can draw the right angle here as well. So for, I decided to label the three side lengths as the house being side length A, the ground being side length B, and obviously the ladder has to be side length C because it's a diagonal. Now, because we have it in a simplified triangle format, let's go ahead and identify which of the three values we know and which value we're looking for. So it says here that the ladder is 1 meter long. So we know that the C value has to be 1 meter long. And it says that the ladder is 0.7 meters away from the house. Now, we can interpret that as being away from the house as this side length. And because it says the base of the ladder is away, we know that this part is away from the house. Therefore, this side length must be 0.7 meters. And so we know that side length B is 0.7 meters. And that leaves us with side length A, which we must solve for. So again, let's rewrite that here. Now, because we have our A, B, and C values, we know what we have and what we're looking for. Let's go ahead and bring the Pythagorean theorem in. So A squared plus B squared is equal to C squared. Now let's isolate for A squared here. And we're doing that by subtracting B squared from both sides. Now let's take the square root of both sides so that we can isolate for side length A, and we're looking for the positive square root because a side length always has to be positive. So now that we've isolated for A, let's substitute our values for B and C, which were given to us in the question. So A is equal to the square root of 1 squared minus 0.7 squared. And because these are decimal values, it's okay if you require a calculator to evaluate it, even if you're, in older grades, because it's hard to memorize, squares of decimals. So let's go ahead and evaluate that. So 1 squared is obviously going to be 1, and then 0.7 squared is 0.49. So A is equal to the square root of 1 minus 0.49, and that's equal to the square root of 0.51. Now it says to leave it in exact values, meaning we can't just plug this into a calculator to get us our final value. We have to solve for this. So let's just break this down step by step. So 0.51, we can rewrite it as 51 over 100. So we can actually rewrite this as the square root of 51 over 100. Now, in order to simplify this even more, we can use a law that we have, which states that when we're square rooting, we can square root the numerator and the denominator separately. So if we wanted to, we can just rewrite this as the square root of 51 divided by the square root of 100. Now, we know that the square root of 100 is 10 centimeters, and it's a whole number. So that means what we can do is we can rewrite A as the square root of 51 over 10, which will leave it in its most simplified format. And because we can't square root 51 and get a whole number as an answer, we're going to leave A as square root of 51 over 10 meters. And that is an exact value, so we know that we're done, and we know that it's most simplified, so we can leave it there. So again, let's go back to our triangle here. We solved for A using the Pythagorean theorem, and we were given side length B and C. So we can see the 3 side lengths have been solved and that we're done with the question because we have all 3 side lengths. So to recap, the Pythagorean theorem is a theorem that we use to relate the 3 side lengths of a right triangle. It says that A squared plus B squared equals C squared, and that the A and B are the legs of the triangle, and that C is the hypotenuse. And if we have 2 side lengths of a triangle, we can solve for the 3rd side length of a right triangle based on and using the Pythagorean theorem. And if we're solving for side length A, B, or C, we can isolate by isolating either A, B, or C to the left side and square rooting it. And this is what the basic format is. If you want to screenshot this or write this down, this is always very helpful to have until you get into the habit of memorizing what it is and being able to isolate for it. So thank you so much for watching. I hope that from this video you were able to learn what the Pythagorean theorem is, how to use it, and different questions where the Pythagorean theorem is applicable, and how to solve different word problems using the Pythagorean theorem, and how to isolate for different variables of the Pythagorean theorem. Again, thank you so much for watching, and I hope to see you in a future video. Bye!